Well, welcome back. We are closing in on this project, video by video. I think we may, depending on how it all goes, once we turn the TV on, it'll be sitting on the bench, with the chassis here, and maybe the picture tube over here, and maybe a speaker over here. I'm gonna hook up a little VCR to it and see if we can't get a picture out of it. I don't know. We'll just have to play that one by ear. But right now, all the recap is done. Everything is done to include the electrolytics. And right here, I tried to solder that wire to the chassis, but I did not have an iron that's hot enough. I mean, it soldered it okay, and it's solid as a rock, but I do not like that. It doesn't meet my standard. You can see it's kind of lumpy looking, dumb looking thing. I don't even like that. If I can let me get this lamp over here. Maybe I can shed a little more light on it. We can see it better. Yeah, there we go. Yeah, that looks really bad right there. Piece of solder run up the chassis. I think, what I need is a hotter iron for that. One of our subscribers asked the same thing. He said, he needs to do some soldering to the chassis. And would he need a hotter iron? And I say, yes, of course you do. You're just going to have to break down and get one. The same applies to me. But I have a little ace in the hole called an FR300, that Halolight. I think I can just use the tip of the Halolight to heat this thing up and get this melted real good to where we get a real good connection to the chassis. Better than this. Now this is good, don't get me wrong, it's solid. But I don't like it. So let me experiment around with that. Maybe before the video's over, maybe I can come up with a better looking thing than that. I don't know. I don't even like that. I'm sure that does not meet Brendan's standards either. Okay, what we're going to do, we're going to take this lid off now while we're waiting to see what we can do with this. We'll go ahead and take this lid off. There's 4 screws that hold it. There's one you can see down in there. I don't know if you can see the head of it shining right there. Then there's another one right here. And there's 2 on the other side. Once we get those out, we can go ahead and pull this entire thing right off. So let's loosen up those screws and get that done. All the screws are out, but this one right here did not line up well enough to where I could get my little socket up in there and get it on the head. I struggled and struggled, and it had been, the way it was situated in there is it was low. It was too low. So I had to somehow get this box to raise up so I could get that socket on the head of that screw. And the way I had to do it was I had to loosen this screw, and there's 2 just like it over here. This one and this one. You just go ahead and loosen them up. Don't worry about it. You loosen them up so the box will move a little bit. And let me see. See, I was able to move the box around just enough to where it would actually raise up enough to get that socket on there. So let's go ahead and turn it around and remove that cover. Now here's something interesting. I hadn't even noticed it till now. Somebody at some point wrote on here in pencil, it looks like good. G-O-O-D. That's kind of cool. I don't know if that was done at the factory or where it was done. Hadn't even noticed it up until now. I've been so concentrating on other areas of the chassis. G-O-O-D. At least that's what it looks like. Either there or goop. With the screws out, let's see if I can get the cover off. There we go. She's sliding right off. Alright, well we need some light over here. Let's see what we got. Well, I'll tell you what we got. We got a lot of dirt. Holy mackerel. Holy mackerel. I'm going to have to get me another can of contact cleaner. Look at that thing. Oh, man. Look at the dirt in there. Whew, man, oh man. All that is, and I'll tell you what it is, it just looks like a standard band switch in a radio. Let me see if I can get a little focus here. Little camera, there we go. It just looks like a standard band switch you would find in a radio. It's got the little tabs. See the little tabs down in there? Got the little tabs, got this, the center rod that turns the center. We have the sliders. Oh, the slider over here. Sorry, I'm getting in the way here, but got the little sliders in there. I'll have to do a little inspection here. We've got, let me see, we got 1, we got 2, and 3. Let me back up here a little bit. Yeah, we got 1, 2, and 3. And this one here also has some tabs on it. That's 4. going to have to do some really good, what I'm going to do right now is I'm going to spend some time inspecting that thing, looking very, very closely, which means I'm going to have to move this chassis this way and that way and this way and that way until I, you know, convince myself that everything looks good. And then I'll go ahead and get a fresh can of QD electronic cleaner and start flushing out in there and see what happens. But you have to be real careful with these coils. Do not mess with these coils. These coils are preset to give certain frequencies. You start screwing around with those coils, you'll notice that they're glued together. There's our cement right there. Yeah, you want to be very careful. See how that coil's glued into place? That's cement between those coils. They don't want you messing with those. Stay away from them. And that includes these little ones back here. They're bent and they're coiled and they're spaced and they're set just right to give you the TV channels you need. Of course, it doesn't matter anymore because all I really need is channel 3 or 4 for my VCR. And I guess I could use a converter to pick up regular TV stations, but I'm not going to do that. There's nothing on TV I want to see anyway. So, but you don't want to be messing with them anyway. You know, be careful. Let me go ahead and do a little poking around. I'll let you know what I find. Well, great news, everybody. Everything appears to be in absolutely perfect condition. Nothing is burned. The contacts are still fairly clean. I got a couple down here. No, they're down in here. They have a little bit of tarnish on them, but no big deal. Everything compared to what, you know, I have been seeing in these TVs that I've worked on, especially that old RCA, for those of you who remember back a couple of years ago, my first TV I ever worked on. Boy, I'll tell you what, there was burned resistors, there was everything wrong in that tuner. But we got her to work. Don't have to worry about this one. I'm going to go down to Walmart, going to get me a fresh can of that QD electronic cleaner, and boy, I'm just going to shower down on it, and then we're going to put the lid back on. That's all. I'm not going to mess around. I'm not going to stick a brush down in there cleaning dust or any of that crap. Just going to spray, spray, spray. I'm going to work the tuner knob and make sure that, you know, the shaft and everything and all the little contacts that around the shaft all get their little fair share of contact cleaner. Wow, big load off, trust me. When we first started the restoration on this chassis, I mentioned that the high voltage rectifier tube socket on the bottom had all kinds of black crap on it, right down the wire. This was, yeah, it was almost like I don't know, it almost looked like a Corona dope or tar or undercoating on a car or that Flex Seal stuff they advertise on TV. It was covering the Corona ring itself, and it was covering the wire that leads up to the rectifier tube, and it was down inside there. It was all around. It was a real mess. Well, I wasn't sure if it was supposed to be that way because it looked like it had been deliberately sprayed on there. This is a little capacitor right here. So I contacted Brendan. I said, what do you think about this? You know, he said, no. He said, that's got to be cleaned off of there. He said, that thing, in his words, he said, oh, you need to make that as clean as a whistle. He said, because that Corona ring, as you can notice, is not centered. He said, you're going to have to fix it so it's centered over the top of those tube socket pins under there. Well, here's what the top looks like, and as you can see, that black crap, I mean, it was really heavy on the bottom, and it's pretty, it's here. It looks like road dirt. It's the strangest stuff. Comes off with your fingers. I'm going to go ahead and clean it up the best I can, but I'm going to be real careful. And I do have a very flexible wire right here. It's a little too flexible where it leads into the flyback transformer here. I need to put some kind of gook on there to cover that up. As you can see, the wax has popped off it from the wire flexing, I guess, over the years when they may have changed the tube in there. I don't know. Who knows? It may have cracked the minute they put the tube in back at the factory. You never know. Other than that, you know, it's a little dirty. And there's another coil down below here. Actually, a couple of coils down below here. I don't see any problem with those either, except they're a little dirty. And this one here is a little separated right there. I'm not sure what that is. Don't care. As long as it's in good shape. The yoke around it is good. I don't see anything broken. I'm not sure what this is right here. Not sure what that is. Looks like a little wire, but I guess I don't know what that is. We'll have to worry about that later. Looks like a loose end of a wire. If the TV doesn't work, guess what? We'll come back to here first. So anyway, right now let's go ahead and get it cleaned up. Alright, I think I've about got it. I've been spraying it here now 2 or 3 times and working the channel knob while I spray it. Move it, you know, just kind of move it around a couple of channels and then spray both sides. I think that's going to do it. Just got to be real careful with it, that's all. And I think she's pretty clean now. We'll know in a little while. Well, now that we've got our tuner nice and clean, or as clean as I can get it, we need to go back and we need to do something about this solder joint right here. This grounded joint right there. It just looks so bad. Anyway, what I'm going to do is I'm going to take this the Hakko FR300. I'm just going to melt that in there. First thing I'm going to do though, I'm going to take a bunch of flux here. I need a little help. I need a little help on this one. So I'm going to put a little flux on there. That'll really help the solder flow better, and it'll make it stick better. Now we may have a little drippage down in there, but not a problem. I have a brush with alcohol. Okay, I'm going to go ahead and do that just like that. Put it on the chassis and the joint. Now what I'm going to do is I'm going to use this Hakko FR300. I'm going to use it as a soldering iron. It'll control all the way up to 500 degrees. From 350 to 500 degrees, and it's done by spinning this little knob, this yellow knob on the bottom here. You got 4 positions. Let me see if I can zoom in here. Kind of tough. There we go. We got 4 positions that we can spin it, and it tells you on the side here what those 4 positions are and what the temperatures are. Right now I've got it set at number 4, which is 500 degrees. We need that 500 degrees. That's what I got it set to. And all I'm going to do is I'm going to use it as a soldering iron. I'm not going to extract it. I mean, let's face it, what is this thing? It's nothing but a soldering iron with a hole down through the center and a pump connected to one end of it. That's all. It's a standard old soldering iron. Incidentally, someone asked me if you can change the tips on these. The answer is yes. You can take this little baby right here and turn it. This comes out, and then the tip comes out of the bottom. You can buy different size tips for it. Okay, if I can get over here, we can get a better look at it. Son doesn't want to play with me today. Anyway, there's the tip. It just slides up in the barrel like so. Goes over there, and then this little handle they give you as part of the kit goes over there, and then you just turn it to the right, and it locks it right in. That's all there is to it. Nothing to it. All right, let me go ahead and heat up the iron, or heat up the extractor. And I think what's going to happen is when I place that on there, we're going to have, I may add even a little more flux. We're going to have a nice, smooth joint. And then we can move on to bigger and better things. I'm tired of messing with this. All right, the deed is done. That looks much, much better than what we had. I like that, nice and solid. Now this old flux, or this old solder here was left over from where it was soldered originally. I'm just going to go ahead and leave that on there, no big deal. Right there is what I was concerned with. Looks very nice, very solid. We'll call this job done. We've got one more little problem here. Not only do we have a loose wire here that's attached to the high voltage transformer, we have another one right here that's just barely hanging on. It's hanging on by about 3 or 4 strands. So what I'm going to do is I'm going to suck off that solder. I'm going to strip it back to about right there, and you know, tin it and put it back where it belongs, nice and tight. I'm going to try to solder it in this position because it has to reach out to this tube right here. So we'll kind of solder it in this position right here. Alright, she's all fixed, but you know, I don't like that. What I'm going to do is I'm going to strengthen it up with a little bit of liquid tape here, I think. Put it on with the screwdriver, just kind of give it a little bit of added strength there, because that liquid tape will dry real good, nice and hard. That'll help it a whole lot. Earlier when I mentioned the Corona ring inside this bottom of the socket here, some of you might have said, what the heck is a Corona ring? Well, in order to tell you what this is, we need to start from the top of the chassis. So let's go up there. Here we are at the top of the tube socket, and when I asked Brendan about this, he explained it this way, and I'll just read you what he wrote in an email, and that'll cover the entire thing. There's no sense in me trying to put it down in my own words when he did an excellent job of explaining it. He said the top cap of the 1B3 high voltage rectifier is the point of the highest voltage in this set, or any television set that has a high voltage rectifier. The top cap being right here. The tube goes in the hole, the cap plugs on top of the tube, just like any other tube we have in a radio or whatnot. Now, at this point, we know that's the highest voltage in the set. Why? Because it's coming out of this high voltage transformer, not power transformer, high voltage transformer. All right, now that we've got that down, we know it's the highest voltage here. Let's go back down to the bottom. All right, back at the bottom, we already know that this tube right here handles very high voltage. And Brendan goes on to explain, when we are dealing with high voltage, any place that presents a sharp point or a sharp edge allows the electrons to pile up on it. Now he's talking about these connections down in here, at that point down here. And remember, this goes out to your picture tube. So we got sharp edges right here down in here. And he said it allows electrons to pile up on it. When there are enough electrons on that point, they can actually overcome the resistance of the air itself and arc right into the air and create a corona. A corona, which is a glowing arc, okay? And it says that ring, being round, wire, and shaped in a circle, allows the electrons to pile up evenly along the ring itself. Its smooth edges never reach enough potential at any single point to arc into the air. How about that? It allows the electrons to pile up along the ring from here, and they can't arc across into the air. I imagine if you reached high enough you could, but you know, the voltage in this set, I imagine it would probably melt if it got too high. Anyway, that's what the ring does. It allows the voltages to pile up here without arcing into the air that you would normally get without it. Now, I can't explain it any better than that. I probably could have searched for 6 months and never come up with an explanation that good. He did a good job on that. That's why I have an electronics mentor, and that's why you should also have one. In particular, for me, it's with these televisions, you know. I mean, I'm kind of a newbie when it comes to TVs, although much of it is the same as radios. But without someone there to explain it in layman's language, I could have probably searched for a long time and not figured that out. Don't be afraid to get yourself a mentor, someone who knows what they're talking about. And I mean talking about almost 100% of the time. Okay? All right. Let's get this thing off right here, check out a coil, and wrap this video up. Let's go ahead and get this cover off. 2 screws hold it on, one right here and the other one down in there. We'll just go ahead and take them out. Once we do that, then we have to apply a little bit of heat to this one side right here, because there's a soldered on leg coming off this tin cover right there. We'll heat that and get it loose from the chassis. Basically what's happening here is they just ground it to the chassis in case there's any, you know, signals that they want to get rid of and not interfere with the coils that we're going to be checking out. So this is a shield. So let's get it off. Alright, here goes. Be careful what I'm touching in here. I don't want to. Just got to heat it up without going crazy on it. She's melting good now. She's melting. Alright, now I should be able to just touch it and pull back on the cover, and it should ease right on out of there. Let's do that. With the cover off, we can see that we have a tube right here, which turns out to be V5, which is a 6 AMB, and then we have a couple of transformers with a primary and secondary in each one. This is L39. This is L40. Okay. Now on the schematic, here's what it looks like. Zoom in here a little bit. Here is L40. Here's L39, and here's our two V5 in the middle, the 6A and B. So what we're going to do, I think, is we'll go ahead and check out L39 over here, and then you can see it'll be about the same over here. So let's go ahead. It says here, coming off of pin 2 of the 6A and B, it runs up to pin 2 on the L39. So here's the 6A and B. Where is pin 2? Pin 2 is right here. This is pin 2 right here. Let me get my pencil on this, back up just a little bit. We don't need to quite be that close. Okay, L2 runs from here over to the connector on this coil right here, which is L39, which is exactly what it says on the schematic. It runs from pin 2 over to a pin 2 on the schematic, on L39. See it right there? Pin 2 over to pin 2. That's great. Now it comes down here. It goes from pin, this is pin 3. So pin 2 and pin 3 to ground. Well, that ought to be easy enough. Pin 2 to pin 3 to ground. Let's see what we've got on our ground up here. We've got, there's pin 3 running over to the ground right there. So all I got to do is take my multimeter and check between here and here, see if I get a reading. If I do, it means the that particular coil is good. So let's go ahead and get that hooked up with a gator wire and the multimeter. Alright, we've got our multimeter hooked to the bottom one here. Let's hook it up to the top now with just the lead. See if we get any kind of a reading. Yes, we do. Remove the lead, touch again. There we go. We have continuity in that coil. That coil is good. Alright, we just checked out this coil right here, which is the secondary. Now we'll go over here, and we're supposed to connect between pin 4 and pin 1. Alright, let's go ahead and move this over to here. If this is pin 2 and 3, then this one over here is 1 and 4, okay? So we'll go ahead and move this over to 1 and 4. And we should, let me go ahead and, if we get continuity, we're going to wrap this video up. Let me see if I can get continuity. Boy, we got a bunch of resistors all sort of jumbled together on that one pin, but it doesn't matter. That's still pin 4. So let me go ahead and touch. There we go. We have continuity in that coil also. So the primary and secondary, the primary and secondary of L39 is good to go, and that's the way you ohm out the primary and secondary of L40, which I have already done, and this coil is also good. And if you want to, you can touch your multimeter from here. Check that little bitty coil while we're at it. Let's go ahead and check that one just to make sure. Let me see. We'll go ahead and touch that little one. There you go. Got continuity there too. Okay, we're good to go. We are good to go. All right. Next time we are going to turn this television on. It will be turned on. But I have to do one more thing before we do. It's something real quick and easy. And that'll be it. I had to confer with Brendan on it, which I have already done, and we're ready to go. We're ready to go for the turn on. So I'll see you there. And until then, this is John.